in lab, you guys investigated the motion of a cart as it was pulled along a track by a hanging mass. And that cart started over here. There was string connected to it, looped over a pulley that allowed a mass to fall. And of course, the ground is way down here. Now, what happened is initially you were holding that. And so there are multiple forces acting on this cart. There's the force from the track pushing up on it. There's the force from gravity pulling down on it. Now, those two forces are balanced. And then there was the force in the string pulling it across the track. And then you guys initially held on to it, so there was the force from your hand pulling back. And under that case, this thing was balanced because every left force had an equal size right force, every up force had an equal size down force. And what happened right there is the velocity was equal to 0 and the acceleration was equal to 0. It did not move, it did not accelerate, it was at rest and it remained at rest. But then you let go. And when you let go, this force went away. And as soon as that force went away, our velocity time graph started to change. So our velocity, measured in meters per second, was initially 0. And it stayed 0 for a little bit of time while you held on to it. So this was hanging out here. But then you let go. And when you let go, it started to speed up. So we got this. Okay, and so under this case, the velocity changed and the acceleration was not 0. You had a cart that started to speed up. Okay? And then this hanging mass hit the floor. And when the hanging mass hit the floor, this force went away. When that force went away, you'll notice the only two forces that are acting on it are, again, gravity and the track. And that means the forces went back to balanced. So initially we had balanced forces. And then we let go of it so the string could act, and that caused an unbalanced force, and the velocity changed. We had a non-constant acceleration. But then we had balanced forces again. However, the cart didn't stop. It continued moving with a constant velocity. So now we have a velocity not equal to 0, but an acceleration equal to 0. It was no longer speeding up, it wasn't slowing down, it was just moving along the track. This is back to a balanced force case. And if we look at that, what we see is a statement of Newton's first law. When the forces are balanced, the acceleration is 0 and the object remains at rest. When the forces are unbalanced, the velocity changes, the acceleration is not 0, and the object's velocity is changing. And when the forces are balanced, the velocity is not 0, but it remains constant because there is no acceleration. And we put that together and we have a statement of Newton's first law, which simply says an object's velocity remains constant unless it's acted upon by an unbalanced force. Okay? That means unbalanced forces cause acceleration. If the forces are balanced, no acceleration occurs. The object could be at rest or it could move with a constant velocity. If the forces are unbalanced, the object will accelerate. That means its motion will change. It will either speed up or it will slow down or it will change direction. If you followed this on to the end, you notice that eventually your cart did stop. This changed fairly abruptly and that went back to 0. And that's because it ran into the end of your track and another force acted on it, slowed it down, stopped it. So it takes a force to slow something down and stop it. And sometimes that's hitting another object and sometimes that is friction. And so when an object gently rolls to a stop over time, it's not because an object's natural state of motion is not moving, it's because friction is a force that causes it to slow down and stop.